In this presentation, I'm going to show you how to plot the probability density function and the cumulative distribution function using a spreadsheet program. In my case, I'm using Google Spreadsheets, or you can also do this in Excel or other spreadsheet programs. So what we're going to do is we're going to actually plot two different probability density functions on one graph, and our first function for a normal random variable has a standard deviation of 1 and a mean of 1, and the other probability density function for a normal random variable has a mean of 3 and a standard deviation of 1. So in order to compute these functions in a spreadsheet, we need to create a set of x values to compute the probability density function with. So we want two graphs with two different means on this one plot, and because we have a standard deviation of 1, we probably want to make sure, we most definitely want to make sure that we cover a plot that, or our graph shows both of these plots, and even though they have two different mean values, we can actually capture that by ensuring that when we choose values for x, we choose values that have standard deviations that are about 2 units below the mean of 1, which is our low mean for one of our normal random variables, and 2 units above our high mean, which is 3 for the other normal random variable. So what we're going to do is we're going to choose values of x, and in this case we're going to start with -1 because that's 2 units, 2 standard deviation units below our mean of 1. And then we just have to sort of arbitrarily choose how we're going to increment up to 5, which is 2 standard deviation units above the mean of 3 in that other probability density function for a normal random variable. And I'm going to choose just 0.05 just so that we can really see or capture a curve. And then what I'm going to do is I'm actually just going to drag this down until we get to that 5 value, which I believe is here. I'm also going to insert the way we sort of denote this, and this column is going to be our probability density function. So in order to compute the probability density function, we're going to use the norm dist function. And in this case, we put in our x value first, so that's just this column here. And our mean in this case for the first one is 1, our standard deviation is 1, and because we're not actually trying to do a cumulative distribution function at this point, we're actually going to return it as false because that'll give us the PDF. So we're going to hit enter, and then we're going to compute this all the way for every single value of x, which is through 5. Then what we're going to do is we're going to plot this. And in order to plot this, we're just going to select data, we're going to make a chart, and in this case we're going to use a scatter. Did it not insert? I don't know where it is. Oh, it's up here. So here's our chart, and you can see that this has a really nice normal probability distribution function. So what we want to do next, I'm going to delete both of these charts because we're going to make a new one, is we actually want to compute now the probability density function for that other normal random variable which had a different mean. So we're just going to denote this as g of x. And in this case, again, we're going to use the norm dist function. Again, we're going to choose our x, but in this case, our mean is 3, our standard deviation is 1, and again, we're going to return this as false because we're looking for the PDF and not the cumulative distribution function. So what we're going to do now is we're going to select and compute this for every single value of x. So again, that's up through 5. And then what we want to do is we actually want to plot all of these together. So I'm going to select these two first. Create a chart. Scatter. And then we're going to add another range. In our case, sheet 1. This is C2 through C122. And we're going to insert it, and we'll look at it up here. And you'll see that we have two kind of beautiful normal probability distribution functions, and they have different means. So the blue, which is the first one we plotted, has a mean of 1, which you can see here. And our second probability distribution function has a mean of 3, which you can see here. So the next thing we want to do is we actually want to now compute the cumulative distribution function. And this is almost exactly the same thing that we've done for the probability density functions for these two not normal random variables. But instead, we're going to denote this as f, large F of x. And when we use our norm dist function, we're actually going to, again, use x, put our mean in. So our first one was a mean of 1. Our standard deviation was 1. But because now we're trying to do the cumulative, we're going to return this as true. And what I'm going to do now is drag this and compute this all the way down. And actually what I'm going to do also is I'm just going to go in and I'm going to compute the cumulative distribution function for our second normal random variable. So again, our x value, our mean, in this case was 3, our standard deviation was 1, and again, it's true because yes, this time we are trying to do the cumulative distribution function. So we're going to do this. Put it all the way down. And now we're going to plot these. So to do that, I'm going to select this one. And this one, oh, take that back. So now what I'm going to do is I'm going to highlight and select this. Then I'm going to select the data, and in this case, I have actually copied and pasted this column here so that it's here, so it's easier for me when I plot the data. And I'm just going to select all of it. And once I've selected it, I'm going to create a chart. And in this case, I'm going to do a scatter plot again. And now we can look at the plot. And you can see that we have two different cumulative distribution functions. The first is for that mean of 1, and the second is for that mean of 3. I hope you now have a better understanding of how to compute probability density functions and cumulative distribution functions and how to plot them. Thanks.